Hi everyone, welcome to Math 150. This is the first lecture. We're going to be talking about solving equations, mostly of the linear style. To begin with, let's try and understand what these things mean. First of all, we're going to talk about equations. These can be defined as relationship between variables. For example, 7x minus 3 equals 16. The important aspect here is the presence of this equal to sign, which makes it an equation. Now, next thing is, what does solving mean? Solving means finding a value of the variable which makes the equation true. For example, if I have an equation which is 2x minus 3 equals 5. Now let's say I plug in x equals 2, then what I get is 2 times 2 minus 3, which is 1, which is not equal to 5. So this is not true. However, if I say x equals 4, then I get 2 times 4 minus 3, which is 5, which is equal to 5, which is true. Therefore, I can say that x equals 4 is a solution. Okay. Now, standard ways of solving, standard methods of solving equations. What we want to do is isolate the variable. Okay. For example, in 2x minus 3 equals 5, the variable x is right here. And we can use inverse operations to isolate x. What that means is, if you have addition, you can cancel that by subtraction. Similarly, if you have subtraction, you can use addition. If you have multiplication, you can use division. And if you have division, you can use multiplication. So in the standard process, so in this particular example right here, because there's a subtraction, I would add 3 to both sides. Now I add it to both sides because it kind of works like a scale, which means that since these are equal, if I add 3 here, I have to add 3 here to maintain balance. Okay, so I end up with 2x equals 8. Now 2 is attached to x via multiplication, so I'm going to divide by 2 to get x equals 4. which is the same solution that we had before. Okay, one more example. Let's say I have 7x minus 3 equals negative 2. Now I'm going to add 3 again. I left with 7x. Negative 2 plus 3 is 1. I divide both sides by 7 and I get x equals 1 over 7. Alright. Now there is a second scenario, what we call solving by cross multiplication. This is used for fractions. Namely, example is going to make it clear. If I have x over 3 equals 7 over 5, then I can multiply across and these expressions are going to be equal. So x times 5 is going to equal 3 times 7, or 5x is going to equal 21, and now we can follow the same process of dividing by 5 to get x equals 21 over 5. Okay, maybe let's look at one more example. In this case I have, say, 3 over 2x equals 7 over 5. So the rules do not change no matter where the variable x is. This ends up being 3 times 5 equals 2x times 7, or 15 equals 14x. Divide by 14 and I get x equals 15 over 14. Okay. Now the next idea is, it's possible sometimes there are more than one variable. In that case, we can solve in terms of other variables. For example, I could have an equation 2x plus 3y equals 7, and I'm asked to solve for x. Now in this case, since we have two variables involved, x and y, we're not going to end up with a numerical answer. But the idea remains the same. I want to isolate x, so the first step is I'm going to remove the 3y term, end up with 2x equals 7 minus 3y. Now 2 is attached to x via multiplication. To get rid of that, I'm going to divide by 2 to get x is 7 minus 3y divided by 2. Okay, so what this means is I can solve for a variable in terms of another variable. Now I could also have been asked to solve for y. In that case, I would start with 2x plus 3y equals 7. I would subtract 2x on both sides to get 3y equals 7 minus 2x, and then divide by 3 to get y equals 7 minus 2x over 3. So you can be asked to solve in terms of any other given variable. Okay. Now there is one last topic in this, or one last idea that I want to cover here. Now in terms of the inverse operations, we saw that addition can be undone by negative, subtraction by addition, multiplication by division, and division by multiplication. Now I'm going to add two new things. Squaring can be undone by square root, and square root can be undone by squaring. So these are new. What this means is, for example, 5 squared is 5 times 5, which is 25, and square root of 25 is 5, so we get back 5. Okay, so in equations, if we have, say, x squared is 36, then to isolate x, we can undo the square by taking square root. Now when I take the square root, I get square root of x squared is square root of 36, and this comes back to x equals 6. So there's also -6, but in this class we ignore that. Okay. So the idea is that x comes out to be 6. So you have another tool for when you're solving equations containing squares. Now let's look at an example here. Let's say you have three variables, a square equals b square plus c square, and you are asked to solve for a. So once again, all we are doing is taking the square root on both sides. Now when you take this square root, this is a, but this remains square root of b squared plus c squared. This is not square root of b squared plus square root of c squared, or b plus c, etc. Okay, it cannot be simplified further. So it remains exactly what that is. Okay, so that's the end of this lecture. See you folks back with lecture 2 again, which is also going to be some of the prereq stuff that we cover before the actual contents of this course starts up. Alright, see you folks next time.